सब्सक्राइब कीजिए आयोटा इंस्टीट्यूट चैनल को और प्रेस कीजिए बेल आइकन को ताकि आपको मिल सके हमारा लेटेस्ट वीडियो सबसे पहले, और ये बिल्कुल फ्री है।
Hello students, welcome to iOTA Institute Online. Today I am going to discuss about the resonance. So let us discuss some few points about resonance. It is an intramolecular process. Intramolecular means within a molecule. For example, we have a propene. Then the resonance will occur between the atoms which are present in the propene molecule, which involves change in the position of pi bond or non-bonding electron. So, resonance is an intramolecular process, and in intramolecular process there is the change in position of pi bond as well as non-bonding electron. Pi bond means double bond present between two atoms, and non-bonding electrons like cation, anion, lone pair. So the position of pi bond as well as non-bonding electron will change, but no change in the position of any atom or sigma electron. But the position of atoms and sigma bond will not change. By changing the position of pi bond, so when there is the changing of position of pi bond as well as non-bonding electron, then this structure can be written as more than one time. Then this structure is known as canonical structure, and it is also known as resonating structure. Okay, so now you can take a screenshot. Resonance are shown with a double head arrow. So this is the double headed arrow which we place between two canonical structure in resonance. Fourth point is canonical structure are only an imaginary or hypothetical structure. Canonical structure do not exist. It is only imaginary or hypothetical structure, and the structure which exists is known as resonance hybrid, and it is contributed by all the canonical structure. Now fifth point is resonance hybrid is more stable than any canonical structure. Now sixth point is resonance is stabilizing process, and it increases the stability of molecule if the potential energy of molecule decrease. Okay, so by decreasing the potential energy of molecule, stability increase. Now seventh point is stability of molecule is directly proportional to the resonance energy. So stability is directly proportional to resonance energy. Now you can take a screenshot. Now let us discuss canonical structure and resonance hybrid of benzene ring. We know that in resonance the position of pi electrons as well as non-bonding electrons will change, and in benzene ring there is only pi electrons. So let us see how pi electron will change its position. We know that each carbon having one hydrogen because carbon have 4 bonds. Okay, now let us take this pi bond, and the pi electron of this carbon will shift here. Now this carbon having 5 bonds, 1, 2, 3, 4, and if this electron will come here, then 5 bond will take place. So one of the pi electron of this bond will shift here. Similarly this carbon also have 5 bonds, so it will donate its one pi electron to another carbon. So this pi electron will move to that carbon. Okay, so this is first canonical structure, and after changing the position of pi bond, the structure become like this. This pi electron will shift here, so pi bond take place between these two carbon. this pi electron shift here, so between these two carbon and this pi electron will shift here, so this become like this, and this is second canonical structure. And we know that canonical structure is not real, it is imaginary structure. So real structure is resonance hybrid. Let us see the resonance hybrid of benzene ring. We know that pi electrons is not localized at a particular carbon, it is delocalized all over the ring. That is, pi electrons is partially present at each carbon. So partially present pi electrons will shown in resonance hybrid by dotted line. Okay, so this is the partially pi electrons which is present at each carbon. So this is resonance hybrid, which is real structure. Okay. Now we know that stability of resonance hybrid is more as compared to canonical structure, and stability will increase by decreasing the potential energy of molecule. Now let us see. This is potential energy and this is structure. So there are two structures in resonance. One is canonical. Two canonical structures are present. This is canonical structure 1, this is canonical structure 2. Now resonance hybrid. So this is resonance hybrid. Okay. And we know that by decreasing the potential energy, higher will be the stability. So stability of resonance hybrid is more as compared to canonical structure. So potential energy of canonical structure is more. And resonance energy. Resonance energy is the difference between potential energy of canonical structure minus potential energy of resonance hybrid. Okay, so difference between the potential energy of canonical structure and resonance hybrid is known as resonance energy. Okay. So now you can take a screenshot. Now this molecule having non-bonding electron and pi bond. So the position of pi bonds and non-bonding electron will change in resonance. So we will give first preference to non-bonding electron. So lone pair will shift here and nitrogen get cation charge. If atom lose its electron, then that atom will get cation charge. Okay, and this get anion charge. So similarly this pi electron will move here and this get cation charge and this carbon get anion charge. So this become neutral, and this is the double-headed bond which we drawn between two canonical structure and to show the resonance. So we get anion, single bond, CH, double bond and NH2 cation. Okay, so this is first canonical structure and this is second canonical structure. Okay, now let us draw the resonance hybrid of this molecule. Cation and anion charge are present, so slightly cation and slightly anion charge are present at carbon and nitrogen. Now sigma bond must be present between atoms of the molecule, and after that partially pi bonds are present between these two carbon and nitrogen. So in resonance hybrid, partially pi bond will shown by dotted line. Okay, so this is resonance hybrid, which is real structure, and this is more stable as compared to canonical structure. Okay, so now you can take a screenshot. Now let us see the resonance hybrid of this molecule. The hybridization of this carbon is sp2. This is sp2, sp2 carbon and sp2 carbon. So the hybridization of each carbon in this molecule is sp2. It means it have one vacant p orbital, so py is vacant. Okay, so this is vacant p orbital. Now we can start resonance either from this side or from that side. So let us start resonance from this side. The pi electron of this carbon will move here. So this carbon get positive charge and this carbon get negative charge. Similarly, this pi electron of this carbon will move here. This get positive charge and this carbon get negative charge. So positive and negative will form one bond, and this is double head arrow which we drawn between two canonical structure. So we get CH2 single bond, CH double bond, CH single bond and CH2, and this carbon having cation charge and this carbon having anion charge. Okay, so this is first canonical structure and this is second canonical structure. Now let us draw the resonance hybrid of this molecule. CH2 CH CH CH2. In this carbon slightly positive charge is present and in this carbon slightly negative charge is present. Now double bond is present between these two carbon and these two carbons. So it is partially present at each atom of the molecule. So in resonance hybrid we will draw partially double bond as a dotted line. Okay, and resonance hybrid is real structure and canonical structure is imaginary or hypothetical. Okay, so now you can take a screenshot. Now let us discuss some condition for resonance. Pi bond should be conjugated with other pi bond. Means in molecule there must be present alternate pi bond. For example, this is 4 carbon molecule and pi bond must be present alternatively in this molecule. Okay, so this is conjugated pi bonds, means alternate position of pi bond must be present in the molecule. Now second point is all participating nuclei must have either only py or pz orbital. For example, furan. We know that oxygen have 2 lone pair and 1 lone pair is present at empty py and 1 lone pair is present at empty sp2 orbital. Okay, so this empty py lone pair will take part in the resonance. Okay, So this lone pair will take part in the resonance and this will not take part in the resonance. Okay. All participating nuclei must have either only py or pz orbital. Okay. Now resonance never occur in case of isolated polyenes. Isolated polyenes, for example, this is molecule and isolated polyene is like this. Means pi bond is not present alternatively. There is absence of conjugated pi bond. So this is isolated polyenes in which resonance will not occur. Okay. Now let us discuss the resonance hybrid of furan. In furan there is two lone pair present at oxygen and in which one lone pair is present in sp2 orbital and one lone pair is present in vacant py orbital. And I have discussed that all participating nuclei must have either py orbital or pz orbital. In furan we have py orbital. So this lone pair will take part in the resonance and this sp2 lone pair will not take part in the resonance. Now let us start the resonance. This lone pair will shift here and this bond will shift here. And this is the double head arrow which we drawn between two canonical structure. So we get oxygen get positive charge because oxygen is losing its lone pair. So the bond will take place between oxygen and carbon and one lone pair is present at this position and this lone bond will place as it is. Now this lone pair will move here and this bond will shift here. So we get canonical structure as like this. Okay. Now this lone pair will shift here and this bond will shift here. Now canonical structure is like this. Okay. Now this lone pair will shift here and this bond will shift here. So we get another canonical structure like this. Okay. Now this lone pair will move here and this bond will move here. So this structure is similar to first canonical structure. Okay. So total number of canonical structure are 1, 2, 3, 4 and 5. Okay. So there are 5 canonical structure in furan. Now let us draw the resonance hybrid. Slightly positive charge is present at oxygen and slightly negative is present at each carbon. Slightly negative or lone pair. We can place negative charge in place of lone pair also. Okay. And now double bond. Double bond is present at this position, this position, this and this. Okay. So this is the partially present double bond in the molecule. So this is resonance hybrid which is real and these are the canonical structure which are imaginary or hypothetical. Okay. So this is the resonance hybrid for furan. Now you can take a screenshot.
सब्सक्राइब कीजिए आयोटा इंस्टीट्यूट चैनल को और प्रेस कीजिए बेल आइकन को ताकि आपको मिल सके हमारा लेटेस्ट वीडियो सबसे पहले, और ये बिल्कुल फ्री है।